Okay, so we did a question similar to this before. What happens to the graph of, in our case, f of x is the absolute value of x. Now, when we graph g of x is equal to 2 times that absolute value, and then 1/2 times that absolute value. So what we want to consider, again, this is our parent function. Let me put that in blue, or in, well, this is our parent function. Of f of x is absolute x, and I think it's helpful if we just graph that. So x, f of x, and let's graph. So again, I'm going to stick with my regular values: -2, -1, 0, 1, 2. I do know that I can plug in a lot more than that. Again, domain is all real numbers, but I know that these are helpful ones. So again, you want to get to a place where you can see this absolute value function, know what it looks like, and have a good idea of what you should plug in. That's the goal. Okay, so we're looking at the absolute value of x. So this is the absolute value of -2. Well, that just gives us 2. The absolute value of -1 is just 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. So I'm going to graph that, again, making sure my graph is labeled and beautiful so that it's easy to read. And let's plot this. So we've got -2 and 1, 2. So we're here. -1 and 1. So we're here. 0, 0. Again, I don't necessarily have to label the origin. It doesn't hurt if you do. 1, 1, and 2, 2. I labeled my other one too high. Bring that one down. Right there. That's better. Okay. So I'm going to sketch this in. Again, trying to draw this without picking up my pencil or, whatever you're drawing with, to make it a lot cleaner and smoother to read. So now we're interested in, well, what happens if I multiply 2 times that parent function? What changes, right? So let's find out. Let's do that. So I'm going to take the absolute value first, and then I'm going to multiply by 2. Order of operations treats absolute value the same way that it does parentheses. So you've got, let's use the same values. So we've got 2 times the absolute value of -2. So again, I do absolute value first, so that's the one outside. And I'm going to rewrite that as a parenthesis. Times this to this absolute value 2, which is 4. -1 times the absolute value of -1. Definitely a 2 still. 2 times the absolute value of -1. So it's 2 times 1, 2. 2 times the absolute value of 0. 2 times 0, which is just 0 still. 2 times the absolute value of 1. 1, which is 2. And 2 times the absolute value of 2. Okay, so we have points. Let's graph them. I am going to keep them on the same one, again, just to kind of see where we go with this. So -2 now is up here at 4. -1 is here at 2. I'm still at 0, 0. 1 is at 2. And 2 is at 4. So again, same overall shape, But what happened to it, right? It's squeezed in a little bit. It's a little different than before. We'll give this a formal name in a little bit, but notice that multiplying by 2 actually caused this function to grow a little bit faster. So its points went from 0, 0, and then when we plug in the 1s, instead of remaining at the 1 output value, they jumped up to 2. And then when we plugged in the 2s, instead of remaining at the 2 output value, they jumped up to 4. So you could kind of see, and again, if you ever need more points, like if this doesn't really sell you on what it's supposed to look like, add some 3s in there or some 4s, and they don't have to be one of each. Like you could just add 3 and negative 4 if you wanted. It's a little bit of an odd choice, but you could just add those. You don't have to necessarily go in order, but again, that's where knowing your function comes in really handy. So now what would happen if we did the same thing with 1/2? So let's use h of x, 1/2 absolute x. So -2, 1, 0, 1, 2. And we're looking at 1/2 absolute -2. Well, that's 1/2 times 2. Half of 2 is 1. 1/2 absolute -1, which is 1/2 of 1. Anything times 1 is itself, right? Don't let the fractions scare you off. 1/2 of 0 is just 1/2 of 0. 0 still. 0. 1/2 absolute 1 is just 1/2 of 1, which is a half. And 1/2 of absolute 2, 1/2 of 2, which is 1. Okay, so same idea. Let's graph. So I've got at -2, I'm here, and I'm going to zoom in a little more. I think I am. At -1, my output was this halfway mark, 1/2 here. Still at 0, back at 1/2, and at 1. Doesn't look like we did a lot there. So again, if you need to add more points to see what this looks like, please do that. Make sure you buy what I'm selling, right? So this looks like that. So similar to how our pinkish graph grew faster, right? The values accelerated because, well, I multiplied everything by 2, right? In the same vein here, if I multiply everything by half, I'm essentially cutting it in half or dividing by 2. That slows it down. So the black graph is our original. That's what it's supposed to look like. Multiplying all of my outputs by 2, right? Absolute value first, that's my output, times 2 accelerates it, causes it to stretch upwards. And then multiplying it by 1/2 slows it down. So what's the rule for this look like? Well, we're going to look at that in just a moment.